In this next lesson, we're going to be moving into equations with two variables. In previous lessons, we learned how to solve equations with one variable, and we learned that the solution to an equation like that was a point that made the equation true. Now we'll be looking at an ordered pair that makes an equation with two variables true. So for example, I want to know whether or not the ordered pair 1, 3 is a solution to the equation y equals 4x minus 1. What I would need to do is figure out whether this ordered pair, 1, 3, remember that every ordered pair is an xy, so the x coordinate is 1 and the y coordinate is 3. I want to know whether or not that makes the equation true. So in my equation y equals 4x minus 1, everywhere where I see an x, I'm going to plug in a 1. And everywhere I see a y, I'm going to plug in a 3. And then I'll simplify using order of operations. If I get a true statement, that means that the ordered pair was a solution. That's what happens in this question. So 1, 3 is a solution to the equation y equals 4x minus 1. However, if I had done a similar problem and at the end my answer might have been something like 3 equals 5, well then that would be no, that ordered pair had not been a solution to that equation. Another way that I can ask you to look at this sort of thing is to find possible solutions given just one coordinate. So here we have the equation y equals 3x plus y equals 12, and ultimately I want you to find the ordered pair that would be a solution if you know that x is negative 2. Before we get into that, we're going to take a step in between and start by solving the original equation for y. Remember, that's where we want to isolate the y, and we're going to use inverse operations to do that. So the inverse of adding 3x would be subtracting 3x. 3x minus 3x is 0. 0 plus y is y. On the other side of the equation, 12 minus 3x, those are not like terms, so that's as far as I can go. I can only write, I can't combine those. I can only go to that point. Now I know that the x value is negative 2, and I want to find the y value. So I'm going to take my equation, and I'm going to replace the x with the negative 2. And simplify. So I've been asked to find y when x is negative 2, and that would be y equals 18. So another way I could write this would be to say that I know that the ordered pair negative 2, 18 is a solution to the equation 3x plus y equals 12. One last representation of the same idea is that I could do it visually. So I've given you a line. This line is for the equation x plus 3y equals 6. And I want to know whether the ordered pairs 1, 2 and negative 3, 3, whether or not those are solutions to the equation. Now I could plug them in. I could plug in the 1 for x and the 2 for y and see if I get a true equation. And same thing, I could plug in the negative 3 for x and the 3 for y, just like I did in the previous examples. But instead, visually, what I could also do is I could plot the points and see whether or not they're on the line. If they're on the line, it means that they're a solution. Otherwise, they're not a solution. So plotting the point 1, 2, that would be here. Here's the point 1, 2. It's not on the line, so the ordered pair 1, 2 is not a solution. Now the point negative 3, 3 is right here. That is on the line. So yes, negative 3, 3 is a solution because it is on the line.